So today we're going to talk about electrolyte solutions and specifically the use of equivalents, or what we really term in the US milliequivalents, to express concentrations. Now the concept of a milliequivalent is unique to the United States. The rest of the world uses millimoles, so of course the US has to do this differently. So you will need to know how to solve problems both for millimoles and milliequivalents. Luckily, there's a nice way to bridge the two that we're going to discuss in a little bit, and that bridge is dependent on valence, or charge of a molecule. So what this means is you need to know your valences, and it is know, not known, know your valences. And this is the valences of some common anions and cations used in pharmaceutical compounds. I would say if you're not used to or haven't dealt with dissociation of compounds lately, it's probably worth going back to some basic chemistry and practicing that. It'll help you both with your valences as well as with dissociations that we'll need for another type of problem we're going to look at later, which is osmolarity. But anyways, so with that warning to know your valences, let's talk about how we bridge between millimoles and milliequivalents. Well, millimoles are easy because you can always figure out the molecular weight of a substance. And the molecular weight, expressed in milligrams, is equivalent to 1 millimole. So that's a set thing that we know. Again, 1 millimole equals the molecular weight in milligrams. And that was an MW here, sorry. Then how we convert from millimoles to milliequivalents is using the valence of whatever compound we're looking at. So with that in mind, let's go through several examples that will hopefully show you all the ways this could come about. In this first example, we're asked to solve for milliequivalents of potassium chloride. And again, milliequivalents is sort of a way of converting the weight in milligrams ultimately to milliequivalents. So what do we know? We know that we have a 50 ml dose of a 12% solution. So the first thing we got to do is convert that 12% solution to an actual weight. So remember, what does 12% mean? Well, 12% means 12 grams over 100 milliliters. However, we're going to be dealing and solving for milliequivalents, so one thing I would do is when you think about this, think about it as 12,000 milligrams over 100 milliliters, so that you don't have to convert your units and get mixed up later. Okay, so with that in mind, let's see what we're starting with. So we have 50 mils of solution. That solution has a concentration for every 100 mils. I apologize. Let me start over. Haha. See, this is why dimensional analysis is important. You can make sure you do everything right. So we have 50 mils. For every 50 mils, we have 12,000 milligrams per 100 milliliters. So we've crossed out our milliliters. And I am able to get to millimoles. Remember, we need to get to millimoles first as our bridge. And what is that relationship? Well, 1 millimole is equivalent to your molecular weight in milligrams. So in this case, we have 80.54 millimoles. So the next step is to get from millimoles to milliequivalents. And again, it's based on valence. So what we have to do is we have to figure out the valence of potassium chloride. We know that potassium is a +1, a chloride is a -1, so the overall valence is 1. So in this case, solving for milliequivalents is actually pretty easy. It's 80.54 millimoles times a valence of 1. So it's also 80.54 milliequivalents. But let's look at some examples where the valence isn't 1. So next we're being asked for milliequivalents of lithium, and how many milliequivalents of lithium are provided by a daily dose of 300 milligrams of lithium carbonate. So first of all, let's go ahead and start at the beginning and start with the valence and figure that out. What is lithium carbonate? Well, Li2CO3 dissociates to 2 lithiums, which are a +1 charge, and 1 bicarbonate, which is a -2 charge. So even though lithium itself is a +1, and we're being asked to solve for milliequivalents of lithium, we still want to deal with the valence of the overall substance. And because of that, our valence in this problem is actually 2, because you have 2 lithiums, not just 1. So I'm going to erase this for room, but keep in mind that when we deal with our valence in this problem, it is going to be a valence of 2, not just a valence of 1. Okay, so with that, we're giving 4 300 milligram tablets per day, and it wants a daily dose. So that means we are giving 1,200 milligrams of lithium carbonate per day. Alrighty. What are we dealing with here? We'll only care about the lithium component, and that's going to be fine. So next is to get to millimoles, since we're already with milligrams. So we know that a millimole is equivalent to 74 milligrams of lithium carbonate. And then we want to know how many milliequivalents, and that's based on valence. So then we have that for every millimole, it's a valence of 2. And we can solve for 32.44 milliequivalents. Now, if you're not comfortable doing full dimensional analysis, what I would suggest is that you simply do the 1200 times 1 over 74 to solve for millimoles, which would be 16.22. And then remember that your milliequivalents is millimoles times valence. And that's another way you can do it to get to that 32.44. And I'm sorry, I wrote the wrong thing here. This should have been 16.22. All right, so if I thoroughly confused you, let's look at 2 more examples, and hopefully that'll help with the confusion. So here we're being asked for milliequivalents of magnesium ion in each teaspoonful of a 2% solution of magnesium chloride. So again, let's figure out what's our valence of magnesium chloride. Well, magnesium chloride dissociates to 1 magnesium, which is a +2, plus 2 chlorides, which are -1. So that means our valence, 2 times -1 is a -2. We have a 1 times a +2, so our valence equals 2. So that's what we have to keep in mind. All right, so let's go ahead and solve the problem. It's asking for how many milligrams are in each teaspoonful. So first of all, we've got to figure out how to get from 2% solution to teaspoonful to figure out how many milligrams that is. So what we know is our 2% means 2 grams over 100 mils, also expressed as 2,000 milligrams over 100 mils. Well, if we only have 5 mils though, then we have to figure out, so it's a simple ratio. 2,000 over 100 mils equals how much over 5 mils. And so we solve that for this, we have a total of 100 milligrams per teaspoon. All right, so now that we've done that, we can start with our 100. So we've got 100 milligrams. We're going to convert from weight to millimoles first using the molecular weight. 1 millimole over 95.3 milligrams as its molecular weight. That's 1.05 millimoles. We multiply by the valence, and we get an answer of 2.1 milliequivalents. All right, let's do one final example. We have a 10 milliampule of calcium gluconate with a molecular weight of 430. How many milliequivalents of calcium are present? So first of all, if you look at this, it looks a little weird. Calcium gluconate, you've got this CH, blah, blah, blah. The calcium's in the middle. But gluconate actually, the gluconate portion itself is the C12H22O14. So if you ever see stuff expressed, just know that the carbons, the hydrogens, and the oxygens are going to go together. Well, crap, I can't remember what the valence of gluconate is. Well, no problem, because you can probably remember the valence of calcium, and there's only 1 calcium. So calcium is a +2, and there's only really 1 gluconate here for the most part, if this is the correct for gluconate, so that would be -2. Or let's say gluconate was actually C6H11O7. It might be, I don't remember. That would mean you would have 2 of them at a -1. But basically, since there's only 1 calcium, you can defer that the valence of this is +2, or is 2 rather. So we're going to use a valence of 2 in this problem. So with that, let's go ahead and solve. So we have a 10 milliliter ampule. Let's go to blue. We've got to convert first to a weight of some sort. We know that it's a 10% solution, so that's 10 grams per 100 mils. But we want to work in milligrams, so we're going to say that there's 1,000 milligrams in a gram. And then we're going to go ahead and convert to millimoles using our molecular weight. So for every millimole, we know that it's 430 milligrams. And we solve for 2.33 millimoles. Now remember, milliequivalence is millimoles times valence, so 2.33 times the valence of 2 that we talked about earlier, we get approximately 4.7 milliequivalents per mil as our answer. All right, so that's about it. So equivalency summary, just to summarize, you got to figure out your valence first. That is step one. Once you do that, figure out the weight of whatever you're dealing with in milligrams, and then once you know that weight in milligrams, convert to millimoles using the molecular weight, because 1 millimoles is the same as the molecular weight in milligrams, and then the simple equation multiplying millimoles by valence will give you your milli equivalents as your answer. Good luck!